Time, something everyone has, but no one truly understands. Sometimes there's too little of it, sometimes it drags endlessly. But what is time? Where does it begin? Where does it end? And what do we do with it? Today, in just 5 minutes, we're exploring the secrets of time. We often think of a second as simply 1/60th of a minute, but it's far more complicated than that. Earth doesn't rotate exactly the same way every day, so astronomical time over the years becomes inconsistent. In 1956, scientists defined a second as 131,556,925.9747 of the length of a tropical year from 1900. Still not accurate enough. In 1967, physicists turned to the building blocks of the universe, atoms. Now, 1 second is officially the duration of 9,192,631,770 vibrations between two energy states of a cesium-133 atom. This atomic definition allows us to measure time with nearly zero error. These clocks are so precise, they'd be off by less than 1 second in 100 million years. Thanks to this definition, our world, from smartphones to satellites, runs on perfect time. Humanity's need to track time is as old as civilization. Around 3500 BC, the Egyptians used obelisks as sundials. Later, mechanical clocks, like water clocks and pendulums, brought more accuracy. In the 1600s, spring-driven mechanisms allowed portable timepieces. Galileo observed the steady swing of pendulums, giving rise to a new understanding of time. In 1656, Christian Huygens built the first pendulum clock. Wristwatches became essential for soldiers during World War I. Then came quartz clocks in 1927, atomic clocks in 1949, and digital watches in the 1970s. Timekeeping evolved with each breakthrough. And now, atomic clocks power GPS, internet servers, even stock markets. Our timekeeping has evolved from sunlight to atoms, but our fascination with time remains timeless. Is time travel just a sci-fi fantasy? Not entirely. In 1905, Einstein's theory of special relativity showed that time isn't constant. The faster you move, the slower time passes. For an astronaut traveling near light speed, a 10-year journey could equal 100 years on Earth. But that's a one-way trip into the future. What about going back? General relativity says it's mathematically possible. Wormholes, rotating universes, even negative mass. They might allow backward travel, in theory. For now, the question remains, what if it's actually possible? The shortest unit of time we know, the Planck time, 5.4 times 10 to the negative 44 seconds. This mattered right after the Big Bang. The shortest event ever measured lasted 10 to the negative 21st power seconds. And the longest, the age of the universe, 13.8 billion years. One day, stars will burn out, galaxies will fade, and only drifting particles will remain. Time will still exist, just with no one left to witness it. If time can bend and stretch, why does it always move forward? That's the mystery of the arrow of time. The answer lies in entropy. According to the second law of thermodynamics, systems naturally move toward disorder. A dropped glass breaks, it doesn't unbreak. As entropy increases, time moves forward. This one-way street might be why we remember the past, but not the future. In 1854, mathematician Riemann proposed that space could have more than 3 dimensions. Later, H.G. Wells imagined time as a 4th dimension in the time machine. Then Einstein tied it all together. He showed that time and space form a single fabric, space-time. It bends and stretches depending on mass and motion. Time is no longer just what we feel, it's part of the very structure of the universe. We'll end with a quote that perfectly captures the essence of time. Don't say you don't have enough time. You have exactly the same number of hours per day as Michelangelo, Leonardo da Vinci, Thomas Jefferson, and Albert Einstein. Craving more science in your life? Tap a video, hit subscribe, and stay curious, where science meets the news every day, right here on BioSci News.